So now we have talked about the various factors which influence breakdown in vacuum. Let us now talk about some of the breakdown mechanisms by which we can explain how breakdown proceeds in vacuum. There are four mechanisms in vogue, four theories in vogue: the Clump theory, the interaction theory, the Cathodic theory, and the Anodic theory. Let us take one at a time. So if we talk about the Clump theory, we are assuming here that under the application of the electric field across vacuum, there is the removal of a charged particle. So let's say there is on the electrode a charged particle which is kind of loosely bound, and so under the application of the electric field, this charged particle will feel a force which tends to accelerate it into the field, and this force may tend to cause it to be removed from the electrode. So what you have is you have the removal of a charged particle or a clump of material from one of the electrodes. So it may not be just one particle, but maybe a very small clump of material which is removed. And this clump is a charged particle also, so it's charged clump, charged material, maybe a conglomeration of particles, and this will now be accelerated towards the opposite electrode. And being a clump, it will have a lot of momentum, and the impact of this with the other electrode will cause localized energy rise. And this localized energy rise at the cathode, there might be sufficient energy to free some more material from the electrode. So from here you get some charged particles or metals, and that charged particle again releases more charged particle or metal from the anode. When these quantities, the amount of particle and the energy that is transferred from one point to another, exceeds a certain value, breakdown can occur. Now, this kind of clump theory can kind of explain how the breakdown progressed, but it is hardly likely that the clump theory can explain the entire breakdown process. I mean, just because some material is being removed from a electrode and being accelerated towards the other electrode, and therefore breakdown happens, it is unlikely. Maybe there are other processes going on, and in the middle of that, this can aid to the breakdown process and cause the breakdown to happen. It is rarely the sole cause. Then you have what is called the interaction theory. In this, you already have some electrons present in the gap. As we have seen, we do not have perfect vacuum, so some electrons might always be present, and these electrons are accelerated by the voltage. They reach the anode, they release photons, they release ions due to ionization of the adsorbed gas. You do not have a gaseous medium which you can ionize, but in a manner similar to the Townsend process, the accelerating electrons can produce ions and photons by ionization of adsorbed gases, which should not have been there in the first place, but they are there. And these ions and photons will then be accelerated back and forth at the cathode. There will be ion bombardment, secondary emission will take place, and by a repeat of this kind of electron and ion impact, ultimately breakdown may happen. So this is another process by which breakdown can be explained. Then you have what is called the Cathodic theory. We have already somewhat talked about this. Under high electric field, field emission occurs from the cathode, from protrusions at the cathode. This is called the Fowler-Nordheim electron emission. Basically, what you need is you need very high fields, and due to the high applied field, there will be even higher local field enhancement wherever there are protrusions on the cathode. Sufficient current density is required before Fowler-Nordheim can cause breakdown. As you remember, I said that if there's a small gaps, it is unlikely that just through Fowler-Nordheim you would be able to have stable current which will lead to breakdown. But for small gaps, it is possible. Micro protrusions, if you have, this may become heated because of current, because of charge concentration and small localized currents flowing. When these micro protrusions get heated, they will evaporate or they may even explode, and there will be current emission. So basically, whatever it is, what is happening is cathode material is being extracted from the cathode and being released into the gap. So in vacuum, either you have particles, or you have gases, or you might have clumps of matter, clumps of metal, or clumps of particles which are injected into the vacuum gap, and these things will ultimately lead to breakdown. This kind of micro protrusion giving rise to cathode current, this is called cathode induced breakdown. So these, apart from that, we have the anodic theory, where a very similar process happens, but not at the cathode, but at the anode. You have electron beams from the cathode, which impinges on the anode. As a result, there is a local rise in temperature. And because of the local rise in temperature, there might be emission of adsorbed gases, or metal vapors may be created. Additionally, due to electron impact at the anode, positive ions may be released into the gap. Again, when these positive ions reach the cathode, they may increase the primary electron emission due to space charge formation. So these electrons are moving around in the vacuum, and it might so happen that the positive ions may reach very near to the cathode, not exactly, but they may form a space charge cloud. If you remember our discussion for breakdown in gases, so you have from the anode, you have positive ion bombardment. Positive ions will move slowly towards the cathode, and there might be a situation where they have not yet reached the cathode, but they form a space charge region in front of the cathode. When they form a space charge region in front of the cathode, there might be a local field enhancement, and local field enhancement may cause discharges. Electron emission may also happen by bombardment of the cathode surface. So these very many factors are there which can lead to breakdown. What is the most important thing is that you can, in vacuum, you can hardly expect that, okay, breakdown will happen here due to anodic mechanism. In this situation, it will happen due to foul or Nordheim. It is not like. These are the various factors, these are the various theories by which the vacuum can sustain pre-breakdown phenomena, and what really happens is probably it's a mix and match of many of these processes which ultimately lead to breakdown in a vacuum. No single theory can explain all the breakdown events, but all of them can contribute in some way or the other. We have also learned what are the factors that we should control to prevent any of these mechanisms from coming into play.